All right, friends, good morning. I hope that everyone had a chance to submit their homework from yesterday. And you guys will notice that submitting your homework is just going to be finishing the assignment on the Pearson portal. It'll be automatically sent to me. I'll have your scores. I'll have that you finished it. And it'll be actually a very easy system for us to use that way. All right, so we don't have to do homework corrections since you received corrections automatically. But that being said, if there are any concepts that you're having trouble with, feel free to send me an email and we'll have some allotted time for asking questions with kind of a Zoom setup. Okay, so we're going to move on today to lesson 6-2, which is on page 341 in your workbook. So what I have pulled up on my screen is the PDF version of your student workbook. So you should be on page 341 and it should look just like this. All right, so this question is asking us to analyze, if you look on the screen, this portion here of this kind of tile piece of artwork. So this is, it looks like a fish surrounded by a nice colorful border, and each tile in the piece of artwork is a square. So if you're looking at this corner here, it's been magnified for us, to answer our question. So each tile is one square. The question asks us, the grid is shaded with blue, orange, and yellow. What part of the grid is shaded blue? What part is shaded orange? And which part is shaded? So shaded at all, any color, okay? So if we're looking at this part of the problem, I'm going to ask you to use the space provided to you in your workbook here to solve this any way that you see fit. So you're going to pause the video for a minute, you're going to try this problem, and when you're ready to come back and share the solution, you're going to press play again. Okay, so just pause for a moment here. So hopefully you found a strategy to solve this problem. And of course, as always, there's not just one way, there are many ways you could have gone about answering this question. So when I looked at this grid, right, the first thing I wondered was how many squares are there in total, right? So if this is a grid made up of squares, what is the total amount of squares in the grid? So I counted across the top and I got 10. So I'm going to label that here in my black pen. So I had 10 across the top. I counted down the side, there was also 10 here. And I thought, oh my goodness, how wonderful. This grid is actually a hundredths grid, which makes solving my problem quite simple. I also noticed that this shape, design, whatever you want to call it, this design was symmetrical. I thought to myself, if I were to graph this or plot this on a coordinate plane, it would be a reflection across the x and y axis diagonally on both sides. So there's 4 quadrants here and they're all identical, they're just flipped, right? So I thought to myself, if I'm going to calculate what part of the grid is shaded blue, I can actually just count how many blue tiles are in one quadrant and then multiply that by 4. So it says how many tiles are shaded blue. So in one quadrant there's 1, 2, 3, 4, 5 blue tiles. So I'm going to use my blue pen here. So I'm going to say there's 5 blue tiles per quadrant. There are 4 quadrants. That's going to give me a total of 20 blue tiles in the whole design. The second part asks me what part is shaded orange. So now I'm going to change my pen to my, see, I don't have an orange. Why don't we use red? It's pretty close. So we'll use red. What part is shaded orange? And in one quadrant I have 2, 4, 6, 8 orange tiles, right? 2, 4, 6, 8 orange tiles. So if I have 8, oh, where did my pen go? If I have 8 orange tiles in one quadrant and I have 4 quadrants, that's going to give me 32 orange tiles in the entire design. Okay, so now I've answered the first two parts of the question. Then the final piece of the question asks what part of the grid is shaded? What part is shaded in total? Well, every single square in this hundredths grid is shaded either blue, orange, or yellow. So 100% or 100/100ths of this grid are shaded. Okay, so the whole thing is shaded, and we know that the whole is going to be represented by 100%, 100/100, which we could reduce to 1/1, which equals 1, which is the whole thing. Okay, so we're going to look at the question on the bottom of the page. Excuse me. It says, write the part of the grid that is shaded yellow as a decimal and a percent. How are the decimal and the percent alike, and how are they different? All right, so I want you to pause the video and try the question. This is at the very bottom of your page on 341. I want you to try that now. All right, so let's answer this question here at the bottom of the page. It asks us to determine which part of the grid is shaded yellow, and to write that, express it as both a decimal and a percent. So the good thing about this grid is it's only 3 colors, and we've already determined how many blue and how many orange squares are in the grid. So since the only remaining color is yellow, and there are 100 total squares, we can add these two together and then subtract from 100. So if we have 20, and it doesn't let me write on the bottom here, I'm not sure why. If we have 20, right, 20 plus 32, so 20 blue tiles plus 32 orange tiles, that's going to give us 52 tiles. So 52 tiles that are either orange or blue, and then the remainder are all going to be yellow. So 100 minus 52 is going to give us 48. 48 plus 52 equals the total of 100. So the thing is that we're not just being asked here, you know, how many yellow squares are in the grid. We're being asked to represent that as both a decimal and a percent. Okay, so what part of the grid is shaded yellow as a decimal? So it's 48/100ths of the grid is shaded yellow, so 0.48, right? That 8, the last digits would land in the hundredths place. And as a percent, that would be 48%. So when we represent percent out of 100, we're going to have 0.48, 48/100ths, right, which represents 48%. All right, so we're going to turn to the next page, which should look like this in your book, to example number 1. All right, and I'm going to actually pull that up on my teacher version right here. Okay. These examples, the videos are not automatically in your student Pearson portal, but I can assign them to you so that you have access to these videos if you would like them. I don't want to overload you guys with material, but if you feel like you need, if you feel like you would benefit from having these videos, you know, just shoot me an email and I can assign them to you. But I don't want you to feel like you have, you know, a massive amount of material that you're responsible for every day. So I don't want to overload you. But if you feel like it would help you, you know, just shoot me an email and let me know. All right, so this first example, on your textbook, you should be on page 342, so we're flipping the page. And this is asking us how do we express percents as decimals and as parts of a whole. All right, so how are we going to do that? This shows us, so if we have, let's see, who's our example person here? Teddy. So Teddy spends time doing homework for each subject that's on the bar diagram. Okay, so Teddy, if we look at the top portion in purple on the screen, the whole amount of time that Teddy spends doing his homework is represented by this purple bar. So now we're looking at, you know, what percent or which portion of the whole is represented by his time spent doing reading, his time spent doing math, and his time spent doing science. Now, in this example, each subject is represented not in the same format, but here we have the representation as a percent. Here we have the representation as a fraction, and here we have it as a decimal. But can we move pretty fluidly between percents, fractions, and decimals? The answer is yes. Okay, so if we were looking to convert, well, first we probably want to choose, you know, what do we want to be our final conversion? Do we want these all to be converted into decimals, all to be converted into percents, all to be converted into fractions? We could do any one of those things. But if we look at the book, they're first going to ask us, how can we write 30% as a fraction and as a decimal? So 30% as a fraction would be 30 over 100, or 3 over 10. Could be written in either of those ways. Those are both equivalent fractions, so those would both work. And we know that 3 over 10 can be expressed as a decimal as 0.3. So that's a pretty easy conversion to make. So 3 over 10, you guys learned how to do this in 5th grade, equals 0.3 or 3/10, right? Then we're going to look at our second fraction here, the amount of time, the portion of the whole that Teddy spends doing math homework is 3/5. So if I were looking to convert this to a decimal and then a percent, what I would do is I would multiply both the numerator and the denominator by 2. I would get 6/10. That would be 0.6. I could also multiply that by 10, which would then be 60%. So 0.6 represents 6/10, which is equivalent to 60 hundredths, which equals 60%. Okay, and then lastly, our decimal here, to convert 1/10 into a fraction, it would be 1 over 10. To then convert it into a percent, it would be 10%. Okay, so those are also fairly easy conversions to make. All right, I would like you to try the try it portion at the bottom of this example. Anna spends 45 hundredths of her homework time reading. What is 45 hundredths as a percent? Okay, and then the second portion, convince me, says what relationship do you see when comparing the equivalent fraction in percent? Okay, so I'm going to have you pause the video right now and try those two questions. Come back when you're done. All right, so if we look at the first part of this question, how do we express 45 hundredths as a percent? So the way that I would think about this, if you're not, you know, terribly familiar with percent, is I would first convert it into a fraction. So 45 hundredths equals 45 over 100, right? If you think about 45 hundredths, that's less than 1, and 45 over 100 is a fraction that equals less than 1. The value of that is less than 1. So that's a way that you can think of it. 45 hundredths as a percent is going to be 45%. 45 over 100 equals 45%. And that, you know, ties into the second part of this question, which asks us, what relationship do you see when comparing equivalent fraction and percent? The equivalent fraction, so whatever the numerator is over 100, the numerator is equivalent to the percent. So anything over 100, the numerator is going to give you the percent. So 19 over 100, 19%. 26 over 100, 26%. Anything that you have over 100, the numerator is going to give you the percent. Okay, so let's move on to example number 2. I'm going to switch this up on my computer here. All right, so let's see. We're still in the same type of example. So Teddy spends 3/5 of his homework time doing math problems. Write 3/5 as a decimal and a percent. The first way that we're being shown that we can write this as a decimal is we can divide. We can take the fraction and divide. So we're going to divide the numerator by the denominator, right? And you guys have this example right here in your book. I'm actually going to switch over to the textbook version right here for a moment because the example is a little bit more clear. All right, so if you look here, this is where we are, the portion where it's asking you to divide the numerator by the denominator. So we're going to divide 3 by 5, and you need to remember that when you have a division problem written this way, that the first number here is actually your dividend, the second number is your divisor, and that's going to switch order when you move it into your little division house. So your dividend is going to go on the inside, your divisor is going to go on the outside. So 3 divided by 5 is going to be 0.6. So 3 over 5 can be written as 0.6 or 0.60, right? Another way we could have done this that might have been a little simpler without doing the division we could just make this an equivalent fraction out of 10.